Well, we're back, and it took a while because I was recording our virtual field trip for the course, and that takes a while. And the scrambling over boulder blocks and scree slopes is not always that easy and time consuming, right? But I want you to get good shots of the outcrop, good photos and videos, so that you better can see what's going on. But you have to know, how do you recognize that I do a regular presentation versus a field presentation? I give you some clues. I have my glasses off for a regular presentation because I have to see the screen. But in the field, you see me with dark sunglasses, like Sylvester Stallone, and my Indiana Jones hat. Well, now you know the difference. This is my field look, and this is my theoretical look. Maybe I should put a tie on as well, a different shirt, but that goes too far for me. So it took a while before I had a chance of doing this second part of the introduction, Geology for engineers and whomever else may be interested. So let's go. Yeah, one of the things that I'm trying to achieve is a shorter video, because I don't want you to fall asleep or being bored to death. All right, so let's keep them to 10 minutes. Let's see, I've got a timer at the bottom of the screen, and we're now 2 minutes on the way. Let me know when you fall asleep. So, what is geology? Well, I looked it up online, and here is one definition that is not that bad. Geology is the scientific study of the origin, history, and structure of the solid matter of a celestial body. Look, we are a little bit modern here because we used to say Earth. Oh. And now we say celestial body because there are geologists that have worked with video material from Mars and materials collected from the moon. So I think the celestial body is very appropriate. But everything starts, and most of our knowledge is regarding Earth, this planet that you and I have our butts on right now. And we study mostly the surface, although we know something about the deeper parts of this planet as well, such as it's darn hot, and the geophysicists, a subdiscipline of geology. The geophysicists, of course, have all kinds of physical measurements deeper into the Earth, starting with seismic and geomagnetics. But most of us, we focus on the crust, the surface, and what's right below it. That part of the rock that has cooled off enough that there is a crust. The skim on a pot of boiling milk might be a nice analogy to what is going on, and we'll show more about that later on. But first we want to say that we study rocks at the surface, and what are rocks in God's name? Or should I say its name? Or maybe there's not even an it. Anyway, rocks are what the Earth's crust is made of. Ooh. the first thing geologists learn is how to observe and describe and classify rocks. So that's what we're going to do. So here is a picture I stole, I think from a geology book. And it shows the Earth. And we cut out a piece so that we can look really nicely inside it. And we have an inner core and an outer core, and then we go into the mantle, and the transition is called the Gutenberg discontinuity. And then we go from the lower mantle to the transition zone and to the upper mantle. And in the upper mantle, it gets interesting because we have in the upper mantle what we call the asthenosphere, which goes from above the transition zone to the base of the lithosphere. And it's a little bit strangely drawn here. Let me use my pointer, because this dashed line represents the Mohorovičić, or the Mohorovičić. I am not very good at languages. Most of us call this the Moho discontinuity. And you can see it with geophysical tools. It's real. And it lies on the border between the lithosphere and the upper part of the mantle, the asthenosphere. Okay. And above that, we have the crust, the lithosphere. Lithosphere is a Greek word that basically means rock layer. Litho is rock. Aha! Lithology is the composition or the makeup of a rock, a sandstone lithology, a limestone lithology. And lithosphere is, of course, the crust. Okay. Next slide. Where do rocks come from? How do rocks form? Well, so here we're looking at, on the left, right here, a pot of boiling water with some wood blocks floating on top of it. And the wood blocks behave a little bit like cork floating in water. And the thicker the cork, the deeper the root goes into the underlying water. And if you put something on top of it, say an ice cap, the cork will sink even further, right? It's all based on the density difference between the cork and the surrounding water, between the density of the lithosphere and the density of the hot molten lithosphere, the molten rocks in the mantle and the core. Now you can also see this as a pot of boiling milk, and then instead of wood blocks you would have the skimmed cooled off milk on the top. And I think that is a better analogy for looking at the crust of our planet. So let's go here to the right, and there you see the convection currents, as we call these things. There are two cells here, the left one and the right one, and they tend to push mantle material up to the center here between the two cells towards the surface. And sometimes the convection currents break through the surface and create volcanoes, in particular submarine or oceanic volcanoes and hot vents, right? And that happens at what we typically call the mid-oceanic ridge. And then the mantle material comes to the surface and flows out on the surface as lava. Lava cools off and starts to crystallize into rocks, right? And the cooled off rocks are heavier in density than the mantle materials. Or I shouldn't say heavier in density, they get heavier because they cool off. And then when they cool off enough, they start becoming heavier than the underlying magma and mantle materials, and it starts to sink. Especially so when on the other side of this subduction zone we have a continent, or older cooled off oceanic crust, but not as old as the stuff that subside below it. In that case you get an oceanic trench there, like the Marianas Trench. Okay, there are a number of different scenarios, but this zone here, where one crust dives below the other crust, we call subduction zone. Okay, so we're back around 11 minutes now, and this is the time to cut the video, and we'll make a little break.